Hello, viewers. In today's session, we are going to discuss some important problems related to the derivative property of Dirac delta function, right? And we have already discussed a lot about Dirac delta function and the problems related to its properties. So here we'll solve four problems related to the derivative property of Dirac delta function. So let us first see the derivative property of Dirac delta function, and then we'll solve the problems. So now consider an arbitrary function f of t, and let us consider the nth derivative of the Dirac delta function, right? So here we have f of t, which is an arbitrary function, and here a delta n t minus a represents the nth derivative of a delta function, right? And then the value of the integral, that is from minus infinity to infinity, and dt is given by minus 1 raised to n. And here we have the nth derivative of this arbitrary function f of t evaluated at the point that is t is equal to a, right? So the value of the integral, that is from minus infinity to infinity, f of t delta n t minus a dt is given by minus 1 raised to n. And here we have the nth derivative of this arbitrary function f of t at t is equal to a. So using this property, we are going to discuss the problems. So now consider this integral, that is from minus infinity to infinity, and we have e raised to minus 4t and delta prime of t minus 1 dt. And here we are going to evaluate this integral with the help of this property, right? Now see, here we have delta prime of t minus 1, that is the value of n is equal to 1. So here the first derivative of delta function is involved, right? And if we compare this integral with this one, then here our function f of t is given by e raised to minus 4t, right? And the value of n is 1, that is the first derivative of delta function is involved. And here we have t minus a, so the value of a is equal to 1, right? So the value of this integral is now equal to according to this property, we have minus 1 raised to n is 1, so here we have 1. And then we have f of the first derivative, that is n is equal to 1, so here we have f prime of a is equal to 1, right? So this is now equal to minus f prime of 1. So the value of this integral is now equal to negative of f prime of 1. So we have to now find out the first derivative of this function f of t. So f prime of t is now given by the derivative of e raised to minus 4t. So we have now the derivative of e raised to minus 4t is e raised to minus 4t, and then by chain rule we find the derivative of minus 4t, that is equal to e raised to minus 4t times minus 4, because the derivative of t with respect to t is 1, right? So we have minus 4 times e raised to minus 4t. So now we have to find f prime of 1. So let us take t is equal to 1. So here we have f prime of t. So f prime of 1 is now equal to minus 4. E raised to minus 4 times 1, taking t is equal to 1. So we have minus 4 e raised to minus 4, that is minus 4 divided by e raised to 4. So substituting the value of f prime of 1 over here, we have now minus, and then we have minus 4 over e raised to 4. So this is minus times minus, this is positive. So we have 4 divided by e raised to 4. So the value of this integral is 4 divided by e raised to 4, or we can also write it as 4 times e raised to minus 4. So this is how, by making use of this property, we can easily evaluate this integral. So now consider this problem. So here we have to evaluate the integral minus infinity to infinity, and we have 2x cube minus 5x square plus 4, and here we have delta double prime x plus 2 and dx, right? So here we see that the second derivative of delta function is involved. So if we compare this integral with this one, then the value of n is equal to 2, because the second order derivative is involved, right? So n is equal to 2, and here the variable is x, whereas here the variable is t, and this is not going to make any difference. So here n is equal to 2, and if we compare here, we have x plus 2, here we have t minus a. So here if we take t plus a, that is the value of a is equal to negative 2, right? So we have x plus 2, and here we have t minus a. So if we take t plus 2, then the value of a is equal to minus 2, right? And our function, that is f of t, and in this case it is f of x. So we have 2x cube minus 5x square plus 4, right? So now according to this property, the value of this integral should be given by minus 1 raised to n is 2, and here we have f double prime, because here n is 2, and the value of a is minus 2. So minus 1 square is positive 1. So we have simply f double prime of minus 2. So now we have to find the value of f double prime of minus 2. So here let us differentiate this function f of x twice, right? So f prime of x is given by the derivative of 2x cube minus 5x square plus 4. So this is 2 times the derivative of x cube with respect to x is 3x square, and here the derivative of x square is 2x, and the derivative of 4 is 0. And here we have 6x square minus 10x. Now the second derivative is f double prime of x. So we have d by dx of 6x square minus 10x. So now we have here 6 times the derivative of x square is 2x, and the derivative of x is 1, right? So we have 12x minus 10. So now the value of f double prime of minus 2 can be obtained by taking the value of x as minus 2. So we have f double prime of minus 2 is given by 12 times minus 2 minus 10, and here we have minus 24 minus 10, that is minus 34. So here we can now write minus 34. So the value of this integral is equal to minus 34. So now consider the third problem. Here we have to evaluate the integral from minus infinity to infinity, natural log of x square plus 4 and delta prime of x minus 1 dx. So now if we compare this integral with this one, then here the variable is x and here the variable is t, and this is not going to make any difference. So our function f of x is now given by a natural log of x square plus 4, and here the value of n is equal to 1 because here we have the first derivative, right, that is delta prime, and the value of a is equal to 1. So here we have a is equal to 1. So the value of this integral according to this property is given by minus 1 raised to n is 1, and we have f prime of a is equal to 1, right? So this is now negative of f prime of 1. So now we have to find out the derivative of f of x. So we have f prime of x is equal to d by dx of natural log of x square plus 4. So now the derivative of natural log of x is 1 over x. So here we have 1 over x square plus 4, and then by a chain rule we have to differentiate x square plus 4. So we can now write here 1 over x square plus 4, and the derivative of x square is 2x and the derivative of 4 is 0. So we have here 2x over x square plus 4, right? So f prime of x is given by this expression, and we have to find f prime of 1 because the value of a is equal to 1. So f prime of 1 is obtained by taking x is equal to 1. So we have 2 times 1 over 1 square plus 4. So this is 2 and 1 plus 4, that is a 2 over 5, right? So taking this value of f prime of 1 over here, the value of this integral is equal to negative of 2 over 5. So now consider this integral. Here we have minus infinity to infinity sine 2t and delta double prime of t minus pi over 4 dt. So now if we compare this integral with this one, then our function f of t is given by sine 2t, right? And here the second derivative of delta function is involved. So the value of n is equal to 2, and here we have t minus a, here we have t minus pi by 4. So the value of a is equal to pi by 4. So according to this property, the value of this integral can now be written as minus 1. Here we have n is equal to 2, and we have f double prime of a is pi over 4, right? So minus 1 square is positive, so we have f double prime of pi over 4. So now we have to find the value of f double prime of pi over 4. So here f of t is sine 2t. So let us first find out the first derivative. So here we have d by dt of sine 2t. Now the derivative of sine function is cosine function, that is cos 2t, and by chain rule the derivative of 2t is 2. So here we write 2, right? So we have now the second derivative f double prime of t. So here we have 2 times the derivative of cosine 2t, and here we have 2. Now the derivative of cosine function is negative of sine function. So here we have negative of sine 2t, and then by chain rule the derivative of 2t is 2. So here we write 2. So we have now minus 4. 2 times minus 2 is minus 4 sine 2t, right? So now the value of f double prime of pi by 4 is given by taking t is equal to pi by 4, that is a is equal to pi by 4. So we have minus 4 sine 2 pi over 4. So here we have minus 4 times sine pi over 2, right? And sine pi over 2 is 1, so we have minus 4 times 1, that is minus 4, right? So the value of this integral is given by minus 4. So viewers, this is how with the help of this property of Dirac delta function we can easily evaluate integrals involving the derivative of delta function.